But now I am very honored to be introducing the co-founder and CTO of AdGuard. So we have Andrey Meshkov with us. He's been involved in the world of ad blocking for a really long time and has immense knowledge in the field. So today he'll be talking to us specifically about ad blocking on Apple platforms. And we're just so grateful that you could join us and give us your time. So over to you.
Hello, everyone. Hello, Kirsten. Thank you very much for the introduction. So, as Kirsten said, my name is Andrey, and I'm a co-founder and CTO at AdGuard, which is a popular content blocking tool available for every platform you can imagine. But my today's talk topic is about content blocking on Apple platforms, mainly iOS. Why do I feel that it's important to talk about Apple? Well, first of all, it's Apple, and it is all over the news all the time, and especially lately. And second, Manifest v3 is coming to Chromium, and I see a lot of similarities between it and Safari content blocking. So let's get going. This is a brief roadmap of my presentation. I will get you through all the content blocking methods available on iOS and tell you about their issues, limitations, and how we solve them, if it's possible. And when it's not possible, I will tell you that as well. But first, let me please introduce AdGuard iOS apps, as I will be using them as an example. So we have two AdGuard apps available on App Store. One is a paid app called AdGuard Pro, and the other one is a free app called AdGuard. And both apps are quite popular and have millions of happy users from all over the world. Well, AdGuard Pro reached top 1 overall in 15 countries and top 10 overall in 70 countries. And AdGuard is often in the top of its category as well. So the point is they're quite popular. Both of them are capable of doing Safari content blocking and DNS encryption/filtering, and they do it pretty well. They are able to overcome most of the Safari content blocking limitations, at least most of the important ones. And I'm going to tell you what these limitations are and what we do to handle them in a moment. But first, let's talk about content blocking on Apple iOS in general. There are not too many options for content blocking. They are the so-called system-wide filtering. This is not a common term, it's like invented by me, and one widely known Safari content blocking. The first one is system-wide filtering, the first one I'd like to tell you about. Please note that by this term, I mean a number of different techniques. I will soon talk about each of them. So it's not as widespread as Safari content blocking for a number of reasons. However, this is the only way you can go beyond Safari and do content blocking in other apps and browsers. Furthermore, system-wide filtering actually was possible even before Safari content blocking was introduced in 2015. Back then, there already was an app, quite a popular app, by the way, called VBlock, which was doing just that. It was one of the first content blockers on App Store, maybe even the first. Now let's talk about different methods that can be used to achieve system-wide filtering. Although there's one thing that unites them all. All of these methods are based on using iOS VPN API. But don't be confused by this. It doesn't mean that there is a real VPN connection. It's just on iOS, and for the matter of fact, on Android as well. The VPN API is the only way to actually filter network connections. I'm using two newly invented terms here, so-called dummy VPN and local VPN. The difference between dummy VPN and local VPN is that the former does not actually work with the device's traffic, or does it, but in a very limited way. It uses VPN API with the only purpose to change the network settings and to set DNS or proxy settings there, and that's kind of it. Local VPN, on the other hand, actually processes all the device traffic, which is heavier and a more complicated task, if you ask me. For instance, let's take Adguard for iOS. It works only with UDP traffic to a single IP address, and that's why it can be considered a dummy VPN. But then there's Adguard for Android, for instance, that covers much more and filters all the device traffic, and I would call it a local VPN. Now that we are familiar with the terms, let's talk about actual techniques. So the first technique we'll take a look at is DNS filtering. Here's how it works. There is a DNS server running locally right on the device. The VPN connection routes DNS traffic from the device, through this server running on the same device. And then this server decides whether a domain is allowed or not. Well, that's simple. But there are some implementation details which are not very important to the topic. But generally, yes, this is how it works. The good examples are DNS Cloak and Adguard. You can Google for them and see how they work. Both of them are capable of doing DNS filtering. You will need to do some manual setup, maybe configure some block lists, because they don't do that out of the box. But still, they are capable of this. The next technique is using a dummy VPN to set a PAC file or proxy auto configuration file. PAC file is basically a script written in a subset of JavaScript that answers to a simple question: what proxy server needs to be used for a given URL? And here's how a content blocking PAC file does that. If a URL should be blocked, the PAC file routes it through a non-existing proxy server. So the connection fails, and voila, the URL is blocked. All other URLs simply aren't routed through any proxy, so these connections continue to work. And by the way, this is actually a very, very old technique. In the very first WeBlock app from 2012, I guess, when the VPN API didn't even exist, the users had to manually configure each of the phone's Wi-Fi networks to use a content blocking PAC file. This was tiresome, but still, WeBlock app was quite popular these days. So people are ready to do some tiresome things to get content blocking on their devices. Next thing I'd like to talk about is a more complicated technique. It's called Local VPN Plus SNI scanning/blocking. The app that does that actually needs to process and scan all the device traffic. It looks for some patterns there. For instance, every TLS connection has a so-called server name indication field in the first packet. From this field, the app can learn the domain name of the remote server, and then it can make a decision whether this connection should be allowed or not. As an example here, I'm using Charles Proxy app, which is not a content blocking app, but it demonstrates how it's done and what information will be available to the filtering app whether you decide to use this method. And now the last and the most complicated technique is local VPN plus TLS interception. This is basically a classic man-in-the-middle approach where the app decrypts TLS connections, parses underlying data, sees the actual requests and responses. And this way, the app has much more information about what's going on. Therefore, it can make better decisions. And I'm using Charles Proxy as an example again, because, well, there are no such apps on App Store, and I'm not even sure that they can be approved. But still, well, maybe they can. You can take a look at how it's done on the Charles Proxy example. So these are 4 main methods, but they can be used all together. So it's not that if you use DNS filtering, you cannot use SNI scanning. You can have all these in your app. But unfortunately, nothing comes without downsides. And there are some issues. As I've said, system-wide filtering is not as widespread as Safari content blocking, and there are reasons for that. First of all, DNS filtering and SNI scanning are limited to domain-based blocking only. It is not necessarily a bad thing, but it is often not enough. PAC file-based approach is a little bit better, but it is easy to circumvent because apps do not have to use that proxy, and often they don't. For instance, Google Chrome comes with a feature called reduced data usage, I guess. And when it kicks off, Chrome starts using its own compression proxy. And obviously, when it is used, Chrome just ignores all other proxies, and therefore nothing is blocked. Also, there's technical limitations. So there is a strict memory limit that iOS imposes on VPN tunnel processes, and it will kill it if the process uses over 15 megabytes RAM. And this makes implementing some complicated stuff like TLS interception quite complicated, much more than it is on Android, for instance. All in all, with these techniques, the overall quality of blocking will be, well, most likely worse than it is compared to the normal Safari content blocking. But this is not the only problem. And here goes the main one, App Store. We at Adguard have a sad history with App Store. So everything was great back in 2015 when we launched the app. But then in 2018, I guess, Apple suddenly decided to ban all the apps that are doing system-wide filtering. We even had to discontinue our Adguard Pro app after that. But then, after 1 more year or so, they changed their decision again. And the guidelines now contain an exemption. You can see this exemption on this slide, specifically for parental control, content blocking, and security apps. So we're back in business. The app gets approved. We start working on a major update, new features, all the cool stuff. And finally, in the beginning of 2020, we upload this major update, and it gets rejected again, with pretty much the same wording as was used 2 years ago. And the reviewer told me over the phone that this is not like his decision. There was some kind of a committee that gathered and that decided that they don't want to have system-wide filtering app on App Store. So in order to pass the review, we had to make some rather drastic changes to the app go through the App Store appeal process, review board, and only then it got approved. And at the same time, I see multiple apps that do very similar things to the ones that we weren't allowed to. And nothing happens to them. My point is, well, App Store may be not consistent. I don't know why. I don't know the reason for this, but be aware. You may pass the review, but sometime later they may gather another committee, and well, your app might be kicked out of App Store. Or maybe this will never happen. You just have to make a bet. Now to a more pleasant topic, I guess. There is no controversy about Safari content blocking. It is definitely allowed, and it is safe to make an app that does it. This is not an easy task, though. So let's discuss the details, the issues, the limitations, and how they can be solved, worked around, or whatever. But first, let's see how Safari content blocking works. So the content blocker is basically an extension of your app that runs in a separate process. And the only purpose of this extension is to serve a JSON object with the list of content blocking rules, which is then used by Safari to actually do the work. Let's take a look at how these content blocking rules look like. They consist of two parts, trigger and action. So the trigger part defines what request the rule should be applied to. And the action part, as in the name, defines what the content blocker does to this matching request. On the slide, you can see a rule that blocks images loaded and style sheets loaded from any website, say for example.org. Please note that the URL filter field is actually a regular expression with some limitations, though some regular expressions capabilities simply cannot be used in Safari. But anyway, and here's a different example. This rule has a different type of action. It basically hides all page elements matching the specified CSS selector. We have just seen two types of actions: blocking a request or hiding an element. But there are a few more actions available. One allows disabling other matching rules, which is very important, by the way. Another one for blocking cookies, and another one for upgrading connections to HTTPS. And that's it. So that's simple. Now we know how it works, and well, it does sound simple, maybe even simplistic compared to modern content blocking extensions. But again, nothing good comes without complications. So let's talk about limitations and issues of this API. And here on this slide, you can see the short list of issues that bother me the most. I will soon go through the list. Fortunately, some of them can be solved. Maybe not fully, but to an extent. And I will soon tell you how. Let's start with something simple, though, and something that doesn't have any solution. Safari content blocking comes with no debugging tools for debugging content blocking. The only tool that filters maintainers have is the browser console, where they can see which requests were blocked. And this is kind of it. As you can see on the slide, well, I guess you can, but anyway, believe me, from the console output, it is impossible to understand what rule is blocking this or that request. And figuring it out may be a very tiresome process. You can just learn that this or that request is blocked, and that's it. This all makes developing filters for Safari a very, very ineffective process. And that is why filters maintainers prefer to use other browsers over Safari when it's possible. This, in turn, leads to the poor quality of the filter lists in Safari compared to other browsers. On a side note, the same issue is typical for Adblock DNS. You can, from the outside, you can see that the request is blocked on the DNS level, but you don't know what rule or block list is causing this. So we developed a simple web service that allows checking what rules and what lists match a specified domain or a request. And it may be helpful to filters maintainers as well, so please feel free to use it. It also partly solves the Safari issue with no debugging tools, because now you have a place where you can find out what rule specifically blocking this or that request. It doesn't fully solve the issue, but it can be helpful. Now to the next point. Adblock filters, EasyList, uBlock filters, and all other filter lists. They're all based on the original Adblock Plus core syntax. It was extended, of course, but the core part is the same among all popular content blockers. I'm talking about basic rules and element hiding rules. I hope you're familiar with it, but if not, you can see a simple blocking rule on the slide, and I hope it will give you the idea. And as you saw on the previous slides, Safari content blocking rules have nothing in common with this syntax. And this is a problem, because we don't want to create special Safari-only filter lists. As we just learned, Safari just does not provide tools for that. What we want is using the good old traditional filter lists like Adblock filters or EasyList. So the obvious solution is to automatically convert our rules into Safari content blocking rules. And as you can see on this slide, this is possible. And we even developed 2 different libraries that do that. There are 2 options how you can do that, though. The first one, you can do it on the server side and prepare JSON files there, and then serve these JSON files to your content blockers. However, there is a serious flaw in this approach. You see, the content blocking rules may affect each other. For instance, a rule from a filter A can disable the other rule from a filter B, and the resulting content blocker will be changed. So if you want to be able to turn different filter lists on and off within the app, you will either have to prepare JSON files for every list combination on the server, or maybe you will have to come up with a more complicated format that will allow combining precompiled lists. And the second approach, just do it real time, right on the device. And we at Adblock use this second approach. And well, these 2 libraries, they can be used inside an app, or they can be used server-side as you wish. So this way we can convert about 90% of all rules of EasyList and Adblock filters. Well, filter list maintainers sometimes have to do some additional work to handle Safari issues because of the missing 10%, but still we're pretty happy with the result. Now to the next point, which is actually pretty massive. because this is the reason for some other important limitations. So the thing is that Safari takes these JSON files and compiles them into a special index structure, some prefixes tree. This is actually a search tree that speeds up the lookups to the content blocker, so that they didn't have to evaluate every regular expression, as this would have been very slow. And it works kind of okay, so lookups are pretty quick. But compiling this prefix tree is quite slow. For example, you can see on this slide the output from the profiler. It takes over 2 seconds on a new MacBook Pro to compile a JSON with just a little over 30K rules. And this is slow compared to content blockers on other platforms. For instance, it takes less than a second for Edgard Android app to parse and compile a list with over 100K rules. The obvious difference, though, is that our Android app uses different syntax, the core syntax, which is not as complicated as regular expressions, maybe not that flexible, but it is specifically optimized for matching URLs. So next, now that we know that the compilation is quite slow, it is easy to understand the next limitation. A single content blocker cannot contain more than 50,000 rules. And this is a hard-coded limit. You can't change it. We were told by WebKit developers that the main reason for this limitation is how slow the compilation is. They may increase it a little bit in the future because new devices are faster, but this will not magically solve all our problems. They will not increase it 5 times. And there is no room for substantial improvement as long as the rules are based on using regular expressions. And this limit itself is a major problem. Edgard base filter plus EasyList have 100,000 rules in total. They simply do not fit into the limit. So what can we do with that? And we can do a couple of things. Now, our converter library, it does not simply convert rules from the traditional syntax to the content blocking syntax. It also compresses it by combining element hidden rules when it's possible, so that multiple element hidden rules are converted to a fewer content blocking rules. You can see on this slide how it's done. I guess if you're familiar with the syntax, you will get the idea. This helps a lot, but, well, it is still not enough. And so the second thing that we do is removing obsolete or rarely used rules from the filter lists that we use in Safari. Here's how it's done. Edgard browser extensions users may choose to help us and send aggregated filters usage stats. This is just a list of rules plus number of usages of these rules. So that's simple. And based on this data, we build a special version of the popular and heavy lists like Edgard base filter or EasyList without obsolete and rarely used rules. But unfortunately, this alone may cause some problems because some rules we just don't have stats about, but they have to be used on iOS as well. So in order to solve this sort of issues, filter list maintainers can use special hints. As you can see on this slide, an example of such a hint from real life. And these hints, they are used to exempt rules from the optimization process. And finally, to the last point, multiple content blockers. As you can see on the slide, Adblock registers 6 different content blockers for Safari. Each of these content blockers is limited by 50K rules. But does it actually mean that 6 content blockers allows us to use 300,000 300K rules? Well, yes and no. It's just not that simple. The problem is that these content blockers are completely independent, and the rules in them, they cannot influence each other. So, for instance, if one content blocker from these 6 decides that a URL should be blocked, the other one cannot undo this. Or if one content blocker decides that some page element should be blocked, it will be blocked. Others just can do nothing about that. But this is not how it works in real life on other platforms. Different filter lists are supposed to interact with each other. And the good example is easily supplementary lists, language-specific list. They may fix issues on some local websites by disabling some of the easy list rules. And well, to solve this, here's what we do. We group filter lists by category and assign each category to one of these 6 content blockers. User rules and allow list rules are added to every content blocker, because obviously this is the only way to make sure that these rules will work. But still, there are some cases when the filter list maintainer wants the newly added rule to interact with some other filter lists from a different category. So in order to help them resolve this, there's another special hint available to maintainers called Safari CB Affinity, which you can see on the screenshot, again, a real-life example. And in this hint, you can specify the name of the content blocker where you would like to add the rule to. And last but not least, content blocking development in WebKit is rather slow, if not to say more. Let's have a look at the changelog of Safari content blocking API. So 2015, it was implemented. So a lot of changes, of course. 2016 added one new feature, a couple of major bugs were fixed. Then 2017, another new feature, which is pretty unusable if you ask me, and added content blockers to WK Web View. And I guess browser developers are happy with that. Brave, for instance, or Firefox Focus, they both use it. And they fixed a couple of bugs. But then it drastically slows down. So 2018 fixed a couple of bugs, some minor refactoring, nothing more. 2019, just a couple of bugs. And 2020, no significant change so far. And note that this is basically the full list of changes implemented in Safari content blocking. Some of you are developers, just compare it to your changelogs. By the way, this year we clicked and Brave and Adblock Plus and some other developers wrote an open letter to WebKit devs and compiled a list of the most pressing issues. There's a link in my presentation. You can check it out. But, this all doesn't mean that WebKit developers undermine content blockers. This just shows us that this is not a priority to them. Or maybe they have limited resources, or maybe both. Well, what can we do about that? And from what I understand, the only option we have is to do it ourselves. Since content blocking is not a priority to WebKit, but it is a priority to us. And WebKit is open source, and they are open to contribution. And this seems the only way we have. We are yet to see how it plays out. We may want to start with a proposal or with a detailed specification of the changes we would want to have implemented in WebKit and see if it gets approved. And well, I hope it does, and then we can implement it ourselves. So if any of you is interested, please contact me later and we can get going. My talk is coming to an end soon, so let's summarize and get to the takeaways. And the first thing I talked about was system-wide filtering. And the first takeaway is that implementing a system-wide solution is indeed possible, but it can be a risky move because, reasons. And next takeaway is that content blocking is not a priority for Apple and WebKit. At least this is how it looks like to me. But still, quality content blocking in Safari is possible, despite all these limitations and issues. But if we want to improve it, we should contribute to WebKit by ourselves. So I guess that's it. Thank you for your attention, and I'll be glad to answer any questions you might have.
There we go. Thank you so much, Andrey. That was really awesome. And we do have one question coming through. So just a reminder for other people, if you would like to post questions, we've still got a bit of time. So Andrey, the one question which has come through and been upvoted is from Shwetank. And he asked if you had the top 3 things to ask the Apple devs to implement to make ad blocking better on their platform, what would those top 3 things be?
I guess the first thing is get rid of regular expressions and start using the normal rules syntax. This by itself will allow fixing the limitation issue, the 50K rules limitation issue. The second thing I would like to have implemented is some debugging tools. As I told, it makes development filter lists for Safari very ineffective. Well, about the third thing, well, I guess I'll be happy with this too.
You'll use all your votes to get extra pressure on those 2. Great, thank you. There was another question that came through from Peter Lowe. Why do you think content blocking isn't a priority? Do you think that might change?
Could you please come again? Isn't the what?
Why do you think content blocking isn't a priority? And do you think that that might change?
Well, honestly, I think that WebKit is kind of low on resources, like in general, and this is one of the reasons. And the second reason is that, well, the current state of content blocking, it allows to handle like 90% of the ads. And Apple might be just happy with this. It could be enough to them. They are not a content blocking company. They don't have a goal of like handling everything.
Thank you. Any other questions from anybody? I'm going to give it a moment just in case there's a few others waiting to come through. All right, then it seems like we can end it there. Thank you very much once again for your time.
Thank
was
you.
incredibly valuable. And yeah, if anyone has any further questions, you can take them over to Slack to the Q&A channel where there's already quite a bit of discussion going on. So we're going to pause here then, and we'll see you all back here in 20 minutes for the next talk.